All right, and welcome to ArcGIS Online, web mapping with arcade expressions. I'm Paul Barker. I'm a product engineer with the ArcGIS Online team. I work quite heavily with Arcade. You may have read some of my blogs, and I'm here with Lisa Berry as well. She's a cartographic product engineer on the Living Atlas team, and you've probably seen lots of her cool blogs about Arcade and some interesting ways on how to use that as well. So I'm going to hop right in here. Let's take a look at the agenda and see what we're going to cover today. So we're going to talk a little bit about what Arcade is and actually what Arcade isn't. And then summarize kind of why you should use Arcade, where to find it so you can actually use it. We're going to go through some simple examples to showcase how you don't need to be an expert in writing expressions or scripts to take advantage of Arcade for some easy wins. We're going to dive into some more complicated examples, and then we're going to touch a little bit on testing, different considerations from a performance perspective, and look at what's next, as well as some resources on where to find help when you need it. So, one of the things that often gets mixed up, Arcade is not named after the classic 80s and 90s mall feature. Arcade is named after the architectural arcade. We have a long history with that naming convention with things like Avenue. So it's a lightweight expression language, really at the end of the day, for manipulating data in ArcGIS. And I think, an interesting way to look at this is to think about the sort of things that you do in Excel and how you manipulate tabular data. We want to do the same with Arcade, but within ArcGIS Online and have it be spatially aware. So you can leverage this in a lot of different places like ArcGIS Pro, ArcGIS Online, the runtime SDKs take advantage of it, as well as the runtime apps. If you're a JavaScript developer, we've got support for Arcade both in 3x and 4x, as well as your web apps take advantage of it as well. And more recently, I'd recommend you checking out what's coming down the pipe with the dashboard beta, because there's some interesting things there that I think most people will find pretty exciting. And I want to stress that you don't need to write complex expressions to add value or make adjustments to your data. There's a lot of simple, little, easy wins that really improve the overall quality of your map and how that data is presented to users, without actually having to write, dozens, if not hundreds of lines of code. So with that, I'm going to turn it over to Lisa, and she's going to take you through what Arcade is, where to find it, and probably show you some examples.
All right, thanks, Paul. So what is Arcade? Arcade is not a replacement for Python or geoprocessing. It's lightweight, so essentially you're going to give it some sort of input. It's going to execute whatever you tell it to do, and then the resulting value is what it will give to you in whatever part of the map that you're working in at that moment. So this is an alternative to calculating a new field, but it really does act just like a field. And you'll notice you can access it anywhere that you normally work with fields. And one of the great parts of this is the fact that means you don't have to own a layer. So if someone in your organization or even a layer that you found online that you're using doesn't have a field in the correct format that you want to use, that's okay. You can use Arcade to calculate things on the fly. Which leads me to this slide, which is why would I use Arcade? And again, because it's an on-the-fly calculation and data manipulation, it means that you don't have to go back to step one. So if you forgot to add a field, or imagine how many times has this happened where you have a numeric field and somehow it gets brought into your database as a text field and then you can't use it the way you want to. That's okay. Also, if you don't know the data, like I mentioned before, and all of these are not a problem, whereas in traditional methods, you'd have to go back to Pro, you'd have to go back to your GDB, you'd have to start, you'd have to recreate your data, and then you'd have to host it back up or fix it or overwrite, whatever it is, and it gets really cumbersome. really fast. And so one of the great things about Excel is the fact that it saves you an immense amount of time because you don't have to go back to square one every single time. And another benefit of it is the fact that it's really easy to get started. You don't have to be a coder or someone who even understands programming languages at all to be able to use this. It's really, you can use it as simple as using Excel. It's very basic and easy to learn, but if you are a programmer or coder, you can absolutely do very complex things. So we'll show you both ends of the spectrum today. And another benefit that you get with Arcade is that it's portable, which means if you make something in your web map, if you create an Arcade expression in your web map, it'll carry through into your apps, your dashboards, your mobile apps. You set it once and it'll carry through. It's also secure, so this was designed with security in mind, and so you know that you're not going to be compromising anything with using this language on top. And also it's geospatial, which we'll show you some examples later, but essentially it is taking into consideration the spatial aspect of your map when you're using it. Arcade is really simple. Like I mentioned, you can use it as simple as Excel. So you can do simple things like write a basic calculation. You can say add these two fields, this field plus this field. Or if you want to create a completely new field, like a constant, you can just say, I want this to be, value X. I want it to be 42. It's very simple to get started, and you can use one of the many built-in functions that are available, or you can reuse existing expressions that are already created within your map. So if you create an expression once, you can then go back and reuse it so that you're not having to rewrite the same expression over and over and over again. So if you see these examples here, you can do formatting, unit conversion, you can add things together, you can rotate symbols. Really, the possibilities are endless. Which brings me to, where do you find this within the map? Where would you actually use Arcade? Symbology, rotation, pop-up configuration, transparency, labels, calculating fields. I mean, really anywhere you use any of your normal attributes, you'll find this new expression line somewhere, or you'll say add expression. And essentially that's just going to act as a normal field. And if you look at this bottom right example, the calculating new fields, that actually is a little bit separate, but you can use Arcade the same way you use it elsewhere. But instead of using the normal SQL calculation, you can use Arcade, and so you can use these geometry functions and whatnot rather than just basic SQL. So there's a lot of power in that. And when you access this new expression that you find throughout the web map, you'll see a window that looks something like this. This section in kind of the middle right is your expression. This is an example one that I have here. You just type in this window. Globals are the other things within your map. So $ feature is the current feature the current feature in your map that you'd be working with, that you'd be calculating. So here you'd see all your list of fields or other layers within the map. Here, functions are all the built-in functions. Each one has help built into it. Constants are things like pi, infinity, and then we also have some text formatting within it. And existing is where you'll be able to reuse other things within your map. And don't forget to test your function. If you want to make sure that it's working correctly, you just click that big blue test button at the top and it'll tell you, okay, this is the type and this is what the resulting value that would be created. So you'd see essentially what kind of data type would be created when you test a function. And with that, I'm going to go ahead and just start showing you what these are like. I'll give you a basic example within a web map. So here I have virtual coral reef stations, and they monitor things such as sea surface temperature and coral reef bleaching. And currently my map is showing the sea surface temperature in Celsius. And as many of you guys probably know, the rest of the world uses Celsius, but us Americans go, what? I don't know what that means. So a basic example of using Arcade is I want to make a version of this so that I can give it to American schools and teach the kids the same value, but in numbers that they can comprehend a little bit better. So in traditional GIS methods, I would be out of luck. I would say, okay, I just have to deal with Celsius, or I'd have to go back to the person who owns this layer, and they'd have to recalculate a new field, rehost their data. But in this case, I'm just going to show you how to access it, and I'll start by changing the symbology, which in the web map is this change style button. So I'll go into there, and just like it has the Celsius field, at the very bottom of the list, there's this new expression. So I'll go ahead and select that, and we'll see that window that I was introducing earlier. So by default, it gives you some commented out instruction, and I'll go ahead and remove those for now. And I'm going to say that this is going to be a sea surface temperature in Fahrenheit. And just so you know, it's a good practice to name your expression something other than custom, which is the default, because this is what's going to show up in the rest of your map, in the legend and all these other places. So it is good practice to give it a name. This is where we'll write our expression, and here you'll see the list of fields. So I want to convert that sea surface temperature. So here's that field. I just click it, and it'll add it into my expression, and I can start doing a calculation. So the calculation to convert is multiply by 5/9 and then add 32. So now that I have a basic equation where I just said multiply plus minus, I haven't done anything crazy, I can click test. It's going to say, here's your result. This is your new value in Fahrenheit, and this is a number. But I'm noticing that this is a really long number, and I don't want that. So I can actually go into the functions and search for the round function. The built-in help, you click this I, and it immediately tells you what this function does. So this is saying I'm going to give it a value and tell it how many places I want to round it by, and it'll return me a number. So I'm going to go ahead and use this function. I'm going to say I want this right here. I'm going to click it. It'll add it in with that help. I'm going to go ahead and paste this guy into that field value and say I want one significant figure. So I click test, and now I have this beautifully rounded number. When I click OK, once I'm happy with my expression, it simply calculates this on the fly, adds it as a new field, and ta-da, I have a new value. I'm going to give it a little bit brighter color like it was before, just so it's a little easier to see. And now my map is showing me sea surface temperature in Fahrenheit. And it's as simple as that. And that's just a basic intro. You can also use it in other places. So let's see how we can reuse an existing expression for something like labels. So if we go into create a label like we normally do, I say I want to use an expression. Here, this existing tab has now popped up. I click existing. Here's that expression I just made. I'm going to give it a name. And it's the exact same thing we just wrote. Okay. I'll make my text white. And there we go. We now have used Arcade in 2 different places in our map, and we're immediately getting a more clear story. I'll show you one more example before we move on to some more complex examples, but I'll introduce you to some more advanced notation. So here we have bird scooters, those things you trip over all over the city that you rent, and it's the little scooters. And if I am the company that owns these and I want to manage these based on how much battery they have, I have a field in my data called battery level. And if I symbolize by this, it's not really giving me something that's useful or easy to make decisions off of. If I need to figure out which ones I need to charge, this isn't really helping me. And this is where Arcade can come in and on the fly help me create something a little bit more digestible. So I'll say create new expression. Brings me to this window that we are now so familiar with. I'll change the name, like I said, to something more meaningful. And I want to actually use, I'll start with a variable. So Arcade is very similar to JavaScript in its notation. So I would say var battery, so var bat equals that battery level feature. Okay, so if I were to say return bat, it would just give me the current battery level, which in this test dummy value is 95. But let's go ahead and create some conditional statements, use some logic. And in the functions, there is what's called if. So if something, do something, and if not, do something else. But in this case, I want to create a spectrum of different values. So I'm actually going to use what's called the when function, which says if something, do something. If something else, do something else. And you can continue this on as far as needed. So I'm going to add this in, and I'll just start saying, actually, I'm going to use, if the battery level is less than 50, those things need charging. So I'll say charge immediately. If battery is over 90, we'll probably say those are good. And we'll say that these ones are fully charged. Otherwise, if it's between 50 and 90, we'll say, oops, sorry, added too many quotes. We'll say charge when able. And so I've now given it something. I could just say test, and that value that we had, 95, is fully charged. Oh, fully charged. So I was able to use a variable, use a function, and create a completely different data type. So actually, you'll notice it changes. It's going to be using unique symbols. So now the ones in red are the ones that I actually am going to need to focus on. And if you wanted to use other cartography skills, such as different symbols, you could use something like this and make the map even more clear to understand, where I know that I need to go to those red scooters. And so those were some basic examples, and now I'm going to hand it off to Paul, who's going to show you much more complex examples of things that you can do to really use Arcade within your map to do these on-the-fly calculations.
All right, thanks for that, Lisa. So Lisa showed you some pretty interesting expressions. I'm going to take a few minutes and walk through some that you can do as well without a lot of actual Arcade writing. So what I've got here is just a data set of water wells from the Ministry of Environment in Ontario. And if I click on the pop-up here, I'm going to see all kinds of information. And I want to draw your attention to depth to bedrock, static water level, and the PDF drill log. Those are the three we're going to talk about today. So if we actually just bring up the table really quick, you'll see that DP bedrock, which is depth to bedrock, and static water level as well are number fields. And an empty value, which in this particular case means not recorded, is 0. Now, if you were to just show the data in the pop-up as is, 0 could be confusing for the geologists out there. Is depth to bedrock 0, meaning that bedrock is in fact at surface and not covered by any soil? Or is it not recorded, which is the case here? So for users, that could be confusing. So we can actually use Arcade to tidy that up, and with really little effort, and so that users don't have to guess. So if I go into configure pop-up here, we're using a custom attribute display, and I'll get to that in a minute, but I want to go to depth to bedrock. If I bring the expression up and take a look, I'm using a pretty straightforward if statement here. And how this works is it's saying if depth to bedrock is equal to 0, then replace 0 with not recorded. Otherwise, get the field depth to bedrock and append the unit of measure as well. So even, this is a Canadian data set, we're a metric system here, so it removes any ambiguity about the units of measure. So if I hit test right now, it's going to pick a sample feature, and you'll see, whoa, Whoa, that's a really long number. We probably don't need that many significant digits. So I'm actually going to go through and just quickly, let's create a variable to store this value. And then we're going to return round. We're going to round depth to 2 decimal places. And let's just test that. Oh, something's wrong here. So what do you think is going on? In this particular case, it's having an issue because there's a string value and we can't just round string values. So we need to take a different approach here. So what I'm going to do is I'm going to quickly go over to an existing expression that I have already made for static water level, which has the exact same problem. I'm going to pop that in using the existing function. So the existing tab here is what actually shows you expressions that are already written for this layer. So I can actually pop this in, and what I'm going to just do is replace this really quickly with, let me just get the exact field name here. And if I go dp bedrock and replace this one. So notice here we're using a slightly different format for the if statement. This it's more structured if format, allows us to build in a little bit of additional logic to things. So we're saying the exact same thing, that if it's equal to 0, then it's not recorded. Otherwise, round it. And so this case, it'll work around the fact that we're not trying to round a string and getting weird results. So if I hit test right now, you can see that I've typed my feature variable name, which is nice. So it gives me a clue about where the problem is. And I hit test, away we go. So 0.6 meters. So I'm going to tidy that up, click that. And now, when we go here, we'll see 5.5, 5.5. See not recorded as well. So pretty easy way to show that and tidy it up. So we've made it clear what units we're using. We've rounded the data to make it a little more accurate. So what's next? Well, if you notice, let me just pull this down here. Apologize, my screen's a little small for the recording. So what I've got is a link to a PDF drill log, the original drill logs from the MOE. Now, not every well has a log, but we'll take a look and see if this one does. Yep, so we're in luck. This has the drill log. So this is actually the original PDF drill log. Sometimes it will contain information that is not in the data model itself, so it's a useful resource. But how did we get that link in the first place? Well, if we look at here, what we've got is we've got a static URL, and then if we pay attention here, so there's essentially a folder or that is the first 3 digits of the well ID, and this in fact is the well ID.pdf. So that doesn't exist in our data model. We've built that dynamically using Arcade. So if we actually go in here and configure pop-up, and we look at our other expression here, that is paper well logs, we'll see another pretty straightforward expression. You notice we're using HTTPS for best practices, and what we're doing is basically taking the root URL, and then we're doing some string manipulation. So we're taking the left 3 digits of the well ID here, and appending that to plus the full well ID plus PDF. So we hit test right now, we'll see that. So you'll see the first 3 digits, and then we'll see the respective URL. So what that allows us to do is that allows us to insert that as an attribute in the pop-up. And so if we go to configure our custom pop-up display here, we'll see that I've done a lot of regular variables that are just in here. And then you'll see some that are expressions. So that's where we're getting the bedrock as well as the static water level. In addition to that, we've got a link. And if I look at the properties of that link using like in the source, you'll actually see that it's referencing the expression. So it's actually when we added this expression in, we did something like this, where we hit create link and we give the URL is the expression, and then the link text is more information. So we've done that here, and so that creates that link dynamically. And so one of the questions we get asked a lot is, can I use Arcade to return HTML? And the answer is right now, no. That's something we'd love to open up, and we're playing with ways to do that and experimenting with ways to do that securely. We are blocking that currently because of security concerns. We don't want to make your pop-ups vulnerable to cross-site scripting and various other attack vectors. So, but you can use Arcade to drive variables within the HTML, like Lisa showed you with color, as well as, in this particular case, using it specifically for the HTML link. So those are some simple ways that you can leverage Arcade to do some interesting things. I want to pop over to a slightly different style of an example. Now, this is a really cool example. It actually involves a lot of math, but it's not really a fundamentally complicated expression at the end of the day. But this is something Doug Morgenthal has written a great blog about, and I encourage you guys to go look it up. And while we think about Arcade as not really, for displaying the pop-up, this one's really interesting. This is a planning tool to help estimate what sort of materials are needed for Sandbag resources. And so at the desktop level, or even in Collector, you could actually go out and digitize or sketch up scenarios and then get a good sense of how much material you need. So in this case, I'm just going to go through and create a dike wall here. We're going to say that this road is in danger, and we're going to come down here. So once again, apologize for the small screen, but we're going to say the sandbag type is a dike, and the finished height, so the max height, all right, when it's done, we're going to say just 2 feet for now. So I'm going to close that, and let's stop editing. And so what's interesting about this is, so we really up until now haven't used Arcade, but when I come back to this feature and click on it, we're going to see a number of things. So you'll see the information we entered, but underneath you're going to see how many sandbags are needed, how much sand itself is needed, as well as whether or not we need any polyurethane sheeting, and that's determined by the dike or the type. So in this case, dike walls require that sheathing. So what it's doing is looking at the length of the feature, as well as the height, and then using known estimates, it's calculating what sort of resources you need for each of those aspects of the dike wall. So one of the things that I'm going to go in here, let's take a look at, let's just say sandbags needed. So it's a little hard to read everything, but we're doing a variety of calculations, pretty standard calculations here. We're not doing anything too out of control. These are standard formulas. So it looks a little more complicated than it really is, but it's looking at the type of the wall and making some decisions based on that. And it's returning the number of sandbags finished. And you'll see right now that it's using length. So if we look up the function length, you can see that it returns the length and of the geometry. So one of the things that, because this is WebMercator, is that length, over larger distances could be a little bit distorted. So in terms of best practices, it's probably a little bit better to come in here and use geodetic. So we use length geodetic, which takes the geodetic length of it and kind of mitigates some of the distortion from WebMercator and other productions. So if we look, we'll actually see, there's 288,000 sandbags needed. If we go back to the old calculation, you'll see there's actually a pretty significant difference in terms of sandbags needed in this particular context, and that's why geodetic would be probably more appropriate here. So let's do that, tidy it off. And that's all I got. I'm going to hand it back over to Lisa. Sorry, my mistake. I got my slides mixed up. I'm going to talk to you a little bit more about adding in additional complexity. So just to recap, we've got a lot of different options at your fingertips. We can leverage variables. We can create user-built functions to reuse. You can drive Boolean logic. You can add in conditional for loops. You can take advantage of geometry functions, and as well as feature sets. And I'll talk about feature sets in a little bit of detail here in a second. So with all those tools at your fingertips, you can do things like access related data. So if you had hydrants and inspections and you wanted to have a single pop-up that kind of brought in some of your inspection related data, you can actually use Arcade to do that on the fly. I just want to call out, we're not showing it here today, but you can actually perform calculations using field calculate. So field calculate allows you to use either a SQL expression or an Arcade expression. And if you're using Arcade, I'd recommend that you keep the data sets to kind of small, medium-sized data sets. It can be an expensive calculation and take quite a bit of time, depending on what you're doing. So use it responsibly, but it can allow for some really interesting calculations, such as like pulling in information about your related records and rendering based on those. And I get asked this question a lot, but can I render based on my related records using Arcade, or why can't I do that on the fly? And the main reason that we can't do that on the fly is really comes down to performance. Those calculations are expensive to do, and for things like labeling and rendering, once your data set got of any significant size, or even past even a small number of features, it could start to get pretty slow, and performance will really suffer and accordingly. So you can't on the fly use Arcade to render, but you can use field calc to periodically calculate your results into the parent feature class and render based on it. So I kind of just made a note about feature sets and then didn't explain it, because that's what I've got here on this slide. So feature sets are just that. They are a set of features. So it allows you to work with many features at once. And essentially that allows you to work with features that are within other layers, or work with all the features within your layer. So it's a way to start to explore and drive spatial relationships. So you could take, maybe you had a point data set and you wanted to find out which county it was within and show the county in the pop-up. You can start to intersect and use all of the rich geometry functions of ArcGIS Online to answer those questions. And so feature sets, because they're accessing multiple features across multiple layers, this is what we were talking about earlier with relationships. You can't use this in rendering, but you can use it in the pop-up, and it's still really effective in the pop-up. So one of the things I'll say is this is really exciting, and when we talk to users about this, people get pretty jazzed about what they're able to do. You do have to use it responsibly. If you're doing really, really complex calculations with multiple loops and accessing multiple data sets and doing geometry operations, you will see a performance hit. It does have to query all the data to answer this. So don't be reckless with them, and use them responsibly, and really pay attention to how that's impacting your performance with your map. And I'll talk a little bit about performance in the next few slides. And with that, I'm going to hop right into some examples. So this is probably the simplest of the bunch that I've got right here, but what you've got is a set of world cities. And if I click on it, any of them, it's going to tell me what country the city is in and how far away it is from its capital. So how do we do that? And obviously, while I'm using world cities, you can imagine this is useful for a variety of different applications. So if we take a look at this expression in more detail, you'll see that I'm doing a number of things here. First, I understand my data set, and what I'm doing is getting the two values that are going to be my filter criteria. I'm getting the feature I clicked on's country name, and then I'm defining a feature set. And so the feature set is actually pointing to the feature layer, world cities. So that's dist to capital. The variable itself is actually the full data set of the world cities. And then I'm getting the capital city itself for that. So what I'm doing is I'm taking the cities and I'm filtering it by these two filter criterias. And you'll see that these variables, when you're referencing them within the filtered criteria, you use an @ symbol to reference those variables. So I'm saying basically, I want all of the features that are either a national and provincial capital or just a national capital and match the country that my feature I clicked on is in. And that makes the feature set as small as possible. So we're not taking the whole data set and looping through everything. We're filtering it first. And the way that Arcade evaluates these is quite lazy. So you can chain these together, like the feature set, filter, and first. And it's not till it's used that it'll execute. So it'll compound all of those functions together to make the query more efficient so that you get the best performance possible. And so all I'm doing here, and I could tidy this up a little bit by breaking some of the ladder functions out, but just to show that it's flexible, I'll leave it there. So what I'm saying is I'm returning the city name is in the country of, and then I get the country name for that city name. And here's the interesting part. I'm looking at the distance geodesic between 2 points. So the capital and the feature. And I'm asking it for distance in kilometers, and I'm rounding it to 2 decimal places. And then I'm just returning that string, that entire string. So that's one big string, and then I'm adding that to my pop-up. So in this particular test feature is Shanghai, and so we can see how far away it is from its capital of Beijing. So nothing too crazy, pretty straightforward, but also really powerful at the end of the day. We've used some spatial functions to, on the fly, showcase spatial relationships between two features. So that's great, that's spatial relationships. And you could imagine that if I wanted to do something like that with traditional relationship classes between features and tables or features and features, I could do something very similar. I could get the feature's primary key, define a feature set, and filter it based for the foreign table based on its foreign key, and then just get the related records. And you've been able to do that for a while with Arcade. But what we've done in recent updates is we've allowed you to we've created a function that allows you to do that more efficiently. So in this particular case, you'll see that we're using a feature set, but it's a special feature set called feature set by relationship name. And so that allows you to define a new feature set based on the relationship. So in our case, we're looking at $feature, which is the feature we've clicked on. And we'll say, I want the features that participate in this relationship. So one thing to quickly call out here, this function does assume that your relationship names are unique. We are going to add another function over time that's feature set by relationship ID, most likely, that allow you to handle cases where under some special circumstances they may have the same relationship name. So, but I bet you're wondering right now well, how do I find out the name of this relationship? So the good news is for when working with $feature, you don't have to. So if I actually drill down into $feature, I'll see the field names, and at the bottom here I'm going to see related records. And if I click related records, it's going to allow me to see the relationships. And if I click this, it's actually going to define everything I need for me so that I don't have to sit there and look at feature service URLs or compare names in geodatabases. So in this particular example, we're doing something very simple. We're just actually getting the feature set and we're getting the count, basically. And all we're doing is saying is if the count's greater than 0, return something, and if the count's less than 0, return something else. So, because we want to tweak the language just ever so slightly. Let's see if I can find one here quickly. So this well has 26 recorded measurements. This one has 129. I think most of these in the data set have measurements. So I think we might be, there we go. There, so this one has no recorded measurements. So another way that you can use conditional statements with feature sets to tailor that pop-up accordingly. So I've got one more example here before I turn it back over to Lisa. And This is another data set that's going to use feature sets as well, and look at some handy functions that make life a little bit easier when trying to do things. So I've got a urban forestry data set. If I zoom in, you'll see all the trees. The trees themselves, individual trees, aren't terribly important. So I'm going to zoom back out here. And what I care about is these neighborhoods in Toronto. And I want to understand a little bit about the trees in Toronto. And I've written a blog about this one too. So there's, if you're wondering, how do I go off and do this afterwards? You can go check out that blog. And there's a live map there with an example. So what this is saying is here's the neighborhood, and it's looking at the top 3 trees, most popular trees, and given the counts. So in this way, particular example, there's Norway maple. There's 283 Norway maple trees in this area. So how do we get there? So if we bring up the Arcade editor, take a little bit of a deeper dive into this example, we'll see that first off, I'm defining a feature set. I'm intersecting the neighborhood I clicked on with the urban forestry layer, which is the individual trees. And what I'm leveraging is this group by function. And this group by function allows me to define a feature set, a group by field, and get statistics. So what we're doing here is common name is the common name of the tree species. So we're going to return the statistics count for the common name. And what that's going to do is group each common tree type and then return the number of trees. So that will give us a list of all the unique tree types within that neighborhood plus the count. But we only want the top 3. And so there's a really handy function here that we can, and 2 functions actually. The first is order by. So we're going to take that list of trees, we're going to order it by the field, and we're going to order it by in descending order so that we get the top ones on top. And then we're going to use this handy top function. The top function is going to pull out whatever number you decide from that object there. So we've said, I want the top 3 of those. And then all we're going to do is loop through that list, and from within there, we're going to just return and keep appending the information. So we're going to loop through those top 3 features, build a string to use in the pop-up. And so for each time we loop through, we're going to get the common name. We're going to add some quotes around the count, and then we're going to add a new line. So if we hit test, that's exactly what's happening here. We're tying in each one individually. And with that, I'm going to pass it back over to Lisa, who's going to show you a few more examples using feature sets and other slightly more complicated functions. Take it away, Lisa.
All right, thanks, Paul. So now I'm going to show you an example of a feature set where I'm actually using data that's not mine, and I'm going to be using what's called the feature set by portal ID. So I'll first introduce us by saying that I want to start with some Living Atlas data. So I'm on the Living Atlas team, so of course I'm going to plug in some of our work. So actually, if you don't know what the Living Atlas is, it's ready to use content, and you can actually find it directly within your map within this Browse Living Atlas option in the map viewer. So if I'm interested in something like housing, I can search for that, and it will give me layers related to housing that are ready to use in the Living Atlas. So, for example, here's a layer that has data from the American Community Survey, which uses census data, and this is updated each year, and it's available to add within my map. So I can add this housing information directly into my map, and I can see that this American Community Survey layer has states, counties, and tracts. And so if I was interested in mapping the tract data, but bringing in county and state values, my map is already pretty cluttered with things, but really I'm only interested in one of these. This is where feature set by portal ID is really helpful, because it just calls to a layer anywhere within the ArcGIS environment, and it will actually grab data from that layer based on its portal ID. So how do you get a portal ID? So I just brought this in from the Living Atlas. This layer is showing me housing. And if I just go into the options and say show item details, it'll bring me to the documented page, the item page for this layer. So this is a Living Atlas layer, which means it's curated content ready to use. And the portal ID is actually this item ID up here in the URL. So remember that when I show this in the arcade window, this number right here is being pulled from this item page in order to calculate something. So now let's look at this map real quick. This is a map of using that ACS layer that we just saw, but using a different attribute. So this is % of occupied housing units that are renter occupied. So where do renters live? And you'll see my map only has one layer in it, but if I click on an area such as Redlands, where we are right now, I see 49% of housing here is renter occupied, but you'll notice I'm also getting the county and state related figures, but they're not in my map. So how is that done? So using some techniques that Paul was showing earlier, we go into here, into the pop-up configuration, and here's oh, that was the wrong one. Bear with me. We'll look at the county rank, or county rate, which is being pulled in, and Paul already showed you an example very similar to this, except for this is using the feature set by portal item function, and here is that ID. So this layer doesn't even need to be in my map, and I can call to it using that number. So you'll see this ends with CCD. Here's this layer, CCD. So we're actually calling to the first layer, which is the county layer in this case, and we're saying I want to filter out the county that this one overlaps with, and I want to pull the % of renters from this. And then we actually did what's called, we did a ranking. So this is where we pull the state value and then used a loop to grab all the values from all the counties in this state, and then we used functions such as index of, reverse, and sort in order to make that list a list from top to bottom. And so you can say, we can determine that this one in particular is, for example, the first in the state. You're the best in all the state, or you're actually in the bottom. So instead of just grabbing a data value from another layer, we're turning it into something a little bit more digestible using Arcade in order to make it easier to understand for our end user. So this example is pretty cool because of the fact that, like I said, my map is not cluttered with other things. People aren't going to be clicking other things. I'm focused on the pattern and subject matter that I want to use, but it's put in a very digestible and simple way. Something similar to that. So imagine I'm in the city of Spokane, Washington, and I have theft crime data. And I can bring in Living Atlas content. For example, we have another layer in the Living Atlas that's about poverty. And I want to use that to create some context in my map of crime. So is poverty and crime related? And I can overlap these and it tells me something interesting, but I want to add additional context to my theft crime layer. So if I go into the pop-up configuration for that layer, you'll notice I have an expression right here. And I'm going to use information from that poverty layer. I use a feature set, grab that information the same way we did in the other examples, and grab the poverty value. But again, I'll use that portal item and actually grab information from a completely different layer that's not in our map, and it's from the Living Atlas. It's actually a population-based layer from the Living Atlas. And this time, instead of doing the filtering, we're using intersects, which is a a spatial query. And here again, we'll do the spatial intersect, figure out how much population lives within the census tract where that crime fell. And then we're actually going to calculate the population density by saying what the population is divided by the area, and then we're going to round it. So we're actually calculating population density on the fly in this section and grabbing the poverty value in this. And then down here, we're going to format it by saying, by using new line, we're using some text functions. So this one in particular says I want to add a comma, 1,000 comma separator. And then it puts it into a digestible form so that when we test this, we're actually getting a more digestible sentence. So the population density, or not sentence, but formatting. This has this much population density, and the percent of population in poverty is this. So when we see this in action, I see one of the, visually I can see that this crime right here, this one right here, is falling within an area that looks like it has a lot of poverty. I can click on it and immediately get more context. Yeah, there's quite a bit of population density in this area. 1,500 people per square kilometers is considered more densely populated, and this area has 1,700. So this is a densely populated area. So there's lots of people that live here, and there's 26% of the population that's living in poverty. So here we used the feature set by portal ID and used the poverty and population, but population's not even in this map. I actually grabbed this from the Living Atlas. And when you guys finish watching this recording, if you've forgotten every single thing that we've said, Paul and I have quite a few blogs. So there's actually a blog that shows almost exactly how to do this example. And so this will be in the resources that Paul shows later. And with that, I'm actually going to hand it back to Paul, who's going to show us how to take this one step further and some considerations to know, as well as what's next in Arcade, because this is an ever-evolving language, and we've been seeing some incredible stuff from users like you. And so Paul has a really good insight on that. And so I'm going to hand it back to you, Paul.
Thanks, Lisa. All right, we're getting towards the end, but I want to talk a little bit about a few other topics before we call it a day. The first of which is how to troubleshoot your expressions. In an ideal world, nothing would go wrong, but in reality, there's going to be times where you've written an expression, you expect it to work, and you scratch your head and don't know where to go next. So I always find planning a really great tool. So I try to plan things out in advance, sometimes on paper, just to organize my thoughts and think about how I'm going to walk through this logically. And I find that helps me write better expressions and cleaner code. We've used the test feature a few times to see that our expressions are good. That's always a good way, and you can tweak variables in that, and I'll show you how to do that as well quickly in a second. A little known function, you can log information out to the console inside the Arcade editor, and that helps you understand where your code might be getting bogged down or to inspect specific variables at various stages of the code. And when you start writing really large expressions, factor reusable logic out into functions. That'll make it easier to read, it'll make it easier to troubleshoot as well. So I'm just going to hop back into the editor for a second here. So we're back in our Sandbag example, and we've got the console function here, we've searched for it. And if I dive in, and it really just logs information out to the console. So let's imagine I was having a problem after these first two variables. So if I add console, and then I can use variables and other things in there, but I'm just going to use a static string for simplicity. And I hit test. You'll see the result. This expression executes successfully because there are no problems. But if we go over to messages, you'll see that we've logged this to the console. So this is the console where we output messages, and this is where you can inspect things. So that means at the very least, if there's an error and you saw this, it got to line 6. So, and just to touch really quick too on the test feature that we were talking about, if you go into $feature, you'll see edit buttons all along here. So we populate the test feature with data from your first record in your data set. But if you wanted to modify it, you can come in here and click edit, and that will let you actually change the test feature value. So you can play around with variables and test different logic triggers that way really quickly before you go off and save your changes. So those are some tips on how to troubleshoot. And let's talk a little bit about queries too. So one of the things shown in this screenshot is we've got our Chrome debugger up, and we're looking at the number of queries that are being fired to execute the expression, and that'll help you assess performance. Which brings me to my next order of business, which is other considerations. So when you're looking at different arcade expressions, it's good to have the Chrome debugger open if you're doing something complicated. It'll give you an idea of how much work the arcade is doing to figure out and fetch the information it needs. So you can see multiple queries, and you can look for opportunities there to consolidate queries in your code so that it works more effectively. And we talked about it a little bit earlier, but feature sets are powerful, but they can be slow if you're not using them efficiently. So it's always recommended to do attribute-based queries instead of spatial queries where you can. And for things like filterable results, so if you pass a filter, if you can, pass it, because the less data you get back from the server, the better. It's going to make your map faster. It's going to have your expressions are going to evaluate more efficiently. And that, last but not least, we talked a little bit about chaining. So because feature sets are executed lazily, which means they don't run until they're actually required to be used in the code. So just defining them doesn't go out and query the data. So that really allows you to chain those functions together to do something where you define a feature set, you filter and intersect it. All of that will get run together at runtime. So we try to be clever about that to save requests and keep things as performant as possible. So those are some tips for today, which brings me to what are we working on next? So there's a few things in the pipe right now that I feel comfortable sharing with you guys. One of the first is bitwise operators, and for those of you familiar with the utility network, they're used quite heavily, but they're an interesting way to store data, particularly things like select all that apply from checkboxes and different experiences like that. One of the other ones we're bringing in for the JavaScript developers in the room, template literals. String literals are a really nice way to write readable code, and we're going to bring that to Arcade so you can use those as well when building strings, and rather than having to rely just solely on concatenating strings together and plus signs, and it's a more natural way to write that. And at the request of a lot of users, we're trying to build in some functions that tell you a little bit more about your data model itself. So being able to get a list of all of the domain values for a field or subtypes for a field and compare that to a value in the feature class to identify, does it sit within the domain? And if not, maybe I should flag that for follow-up. So some of these things are really useful in the realm of attribute rules, but they also kind of have value outside of those profiles. And then last but not least, thanks for staying with us. So when you need help, where do you go to get it? So we've got this great link here at the top, and then Lisa has a PDF hosted there that helps you find blogs about Arcade, links to story maps that are useful. We have a GitHub repo as well, where we've contributed interesting expressions as well as some of our users. So it's a great way to kind of just get inspiration, and then each one of those, I think, has a real example that's kept up to date. So you can go there, look at the code, try it out in the map viewer, and away you go. And as always, the developer site has the full documentation. There's lots of great information there on how to work with Arcade, and little snippets here and there, as well as a playground where you can test stuff in the editor as well. And last but not least, we've got a small group of curated maps where we showcase some good examples of Arcade as well through just a group in ArcGIS Online. So I'll touch on this. This is an area that we are looking to do some more work in, and I probably should have included in what's next, but we want to make it easier for you to share Arcade expressions, between yourself and your own maps, as well as to other users within your organization or even the general public. So we are looking at ways to do that. And you'll probably see some more details on that later on this year. And with that, thank you guys very much for listening. I know the format was a little bit different this year, so appreciate you watching. And thanks to Lisa for being a great partner for presenting. And we'll see you hopefully in person next year at the Dev Summit. Thanks.